Think education, think Raisoni. Raisoni Group of Institutions is one of the largest and premier education conglomerates of India with over 40 world-class campuses spread across the country. Impressive campuses, great infrastructure, high academic excellence, latest technologies and state-of-the-art laboratories, impeccable placement records in the world's best corporations, high standard research facilities, incubation center for entrepreneurship. These are the trademarks of the Raisoni Group of Institutions. Our 25,000 students are constantly exposed to the corporate world and gain international exposure across the globe. Raisoni provides education in engineering, management and 75 different academic programs under just one umbrella. Conquer the corporate world and achieve your aspirations. Acquire the key to professional success. Train for life. Raisoni is the best investment you can make for your future and the future of your child. Raisoni, a vision beyond.
Deputy Director Dr. Sir, Supervisor Dr. Tarnik Sir, Dean R&D Dr. U.S. Wankhede, all deans, heads, faculty members and dear students, a very good morning to one and all. I, Shubhangi Giripunje, Associate Dean R&D, feel privileged to welcome you all to the Ph.D. pre-submission seminar of Ph.D. scholar Mr.K.G.Bante from Electrical Engineering Department on the topic Industrial Power Electronics and PLC System Solution for Enhancing the Performance of DC-AC Drive for Specific Application. Dr. Shastri Vedula is a professor from Electrical and Electronics Engineering, Gayatri Vidya Parishad College of Engineering, Visakhapatnam. He has completed his PhD from IIT Kharagpur in 1968 and postdoctoral from Technical University, Germany in 1973. His professional interest is in object-oriented modeling, embedded programming and control, rapid prototyping, and power electronics and motion control, and electrical machines. His professional experience in IIT Madras from 1968 to 1998 with different capacity. He has international experience about 14 years. I would like to invite Dr. P.V. Nagarnaik sir to present floral bouquet to respected guest Dr. Shastri V. Vedula sir. Thank you sir. I now request Mr. Bante to deliver the PhD pre-submission seminar.
Good morning everybody. Today's presentation on industrial power electronics and PLC system solution for enhancing the performance of DC and AC drive for the specific application. Here the specific application is related with the rolling pin. The basic idea for selecting this is that nowadays we are facing the power stress problem in our country. So we are trying to save the power energy by doing such types of small research. This entire work is supervised by Dr. Tarnekar and Dr. Tudakne. The contents of this presentation, introduction, in this chapter I will explain you the research area of this research, then the literature survey, then the data collection and the data analysis required to fulfill the control philosophy of this research work. Then the possibility of checking the system implementation, whether we can implement the proposed system with the data analysis. Then the development of the models, the different types of model developed, that will I explain in this chapter. Then the integration of all the models. Then algorithm designed for the DC and the AC motor. Then the modified scheme animation, so we can understand that how the modification scheme will work. Then the result, final result and of the modified scheme, conclusion and future scope, then the public reward and the reference.
How much time you are planning to take?
So it will take 40 minutes or 50 minutes. Then this is.
Are you comfortable if you ask me questions right in the middle?
No problems.
Your reason is again coming back and.
No sir, we can answer at any time. No problems. So this is the single line diagram or the flow of the generalized steel industry. So here this part is this complete research work is for the sunflag steel. This is only the part is not is the part of sunflag steel. So this the rolling mill is the interest of the research work. Next. So this is the overview of the research work. We start the video. Overview of the research work, and this the backup mill. This backup is the focus of the research work. Here the mill, the backup mill is fitting to all the three lines, that's the cooling bed, garret and the this block mill. So this video clip I want to show you that where the exactly. So these are the coolers where this research work I carried out, and these are the board which are controlled by this PLC logic and all these things. So this mill is called the continuous steel mill because the material start from the stand number first and it continuously go to the other stand without break. That's why it's called continuous mill. So this part is called the roughing mill part. Then after that intermediate and then the finishing. Here this is called the stand. This is connected with the universal stack with the gearbox to the motor. So the load is transferred from this to the motor. So
when you say motor, please clarify whether that is a DC motor or induction motor.
For this particular case, this is the main drive is the DC motor and the blower is the AC motor.
So it's very common
Yes.
for industrial people to say motor.
So then this is the another is the bloom mill. Here this is the AC motor, sir. This is the AC motor, and this bloom mill is the single stand mill. That is what is suggested by the expert. They include the AC motors also in the research. That's why this part is included here. So next. So this is the another view. The two motors are connected to the single gearbox, and this single gearbox is driving the single stand.
What is the gearbox ratio?
Yes, sir.
What is the gearbox ratio?
Ratio is this one 50:1. Now these are the different the cooling system arrangement for the DC motor. This is the circulated air cooling system. This is normally used for the small motor. This is the forced cooling system, and this is the circulated water cooling system, and this is the area of the interest of research work. Then next. So this is the different arrangement for the AC motors. This the motor 1250 motor without any cooling system. Only the shaft mounted impeller is there, which is sufficient because this is running unregulated motor. So what the cooling is sufficient. Here this is the regulated motor, so that's why the external arrangement is provided here. When this motor is running at the low RPM, then this the cooling can be adjusted by the external cooling system. And this is our area of instance, this cooler where we have carried out the research work, and this is the regulated motor. This can run at the lower speed or the high speed. So this I want to show you that how this cooling system, this is DC motor, this is an AC motor. So this is the cooling system. That cooling system is entirely separate with the motor. So this is the system animation of how the cooling system will work. So this is the heat exchanger from where the hot air is received by this and then it cooled and then it passed through the motor. So this scheme is same for the AC as well as the DC motor. Next. So this is the conventional starter used for the blower of the AC or the DC motor. Now here we know that this is the normal dual starter. That's why we can say that the power consumption of this blower motor is at the rated. Here we can find that the rated of the motor is 11 kW, even though it shows that the 11.3 or 11.6. This is depends on the input voltage. If there is a change in the input voltage, this output will change. Now the literature survey is carried out from 96 to 2011 and it is divided by me in the 3. So the interest of this, the model for the optimizing the running, because both the two are considered in the design state only. Then the conclusion of drawn from the literature survey that I choose the 9th paper, and from that paper it is concluded by me that the dynamic cooling system is the untested area. This forced me to work on this area. So, and the cooling system will work on the load and the temperature dependency. So the aim of the research work is to enhance the capacity of the DC motor and the energy saving on account of the cooling blowers auxiliary drive. So this is the data collection part. So data collector part is divided in these 4 headings: the main motor, load motor data, heat exchanger data, load. This is very important that the load of the main motor and depends upon the different grades and the sizes of the rolling. The main motor temperature. Then the analysis of that of this data is used in the control philosophy for developing the control philosophy. The part of this data table I will show in the next slide. This is the sample data collection for the blower and motor and the main motor. Next. So this is the data for the heat exchanger. Here it is very interesting that the 60 kW, the heat dissipation capacity of this blower motor. So then this is the programmable logic unit to check whether the existing system is providing the facility for the implementation of this work or not. That's why I check the PLC also. Next. So these are that how I collected the data, the features I collected, what are the features in the ABB, so it can be checked with the requirement. Next. So these are the IO, whether the spare IOs are available for implementing the system. Next. So this is the data table. I divided this data table in this load categories. The more data is available there. So and this the colors I had given that for the simplicity. This is the sample table and more data is available. Now the main motor temperature is checked for the 1 month and it observed that the temperature of the DC or the AC motor, main motor, is between 40 to 80 degree. Sometimes it increases above the 80 degree if the load on the motor is increased beyond 100%. Then this is the analysis of the heat exchanger. Here I can find that my requirement is the 55, but the design capacity is 60. So this will work. Next. So this is the analysis table. Here I find that at what grade, how much stands are at what load. So this is very important for designing the system. Next, more data is available by clicking. So now this is, I plotted all this graph, and here I can easily say that if this is grade is rolling or this size is rolling, the how many stands are required for the rolling. And this is done for the comparison based on the load. So I can easily say that for this section, how many stands are at how many load percentage. So this I had done for the flat rolling also. Then next. Now I check this with the size 11 with the grades. So here the different grades, I find that the load is not constant, even the same size rolling is there. It changes with the grade to grade. Now this I check for the round 9 also for more accuracy. Now the main task is that to choose the proper system which can work for this. So I checked that after the collection of data, it was concluded by me that what the system, dynamic cooling system proposed by me will work. Okay, so it is required to design the suitable system. So I first checked that whether the blower on-off system will work. So the limitations are there, it works, but we know that with the dual starter, the starting current is high, so this will work when the wheel stoppage is more. So this limitation overcome by providing the VFD. So the smooth startup is there, but again that it is the question mark that how to control the VFD. So then for controlling the VFD, because without controlling the VFD, the system is not dynamic. So then the VFD control is checked, and the fuzzy logic and the PLC logic is considered by me. So as advised by or suggested by the expert, I studied the fuzzy logic in more detail. After receiving the suggestion, then inference is done for this fuzzy logic that the load on the main motor varies by 5 to 10% continuously, has the fine control or the changing in the reference continuously oscillate the blower. So this is not recommended. The another thing is that the fuzzy logic control, the additional saving with the fuzzy logic control is the almost approximately 3%, that will come around the 2 lakhs, and the investment if I do the fuzzy logic with this, it is around 8 lakh rupees. So the payback period for this is almost 4 years. So and in the industry the payback period, the more than 1 year is not acceptable. So the fuzzy logic system, then I concluded that if I want to use the fuzzy logic system, it can be used when we are purchasing the new system, new installation. In that case we can use the fuzzy logic, it will work. So hence the concept was not worked out rigorously. So however the result confirmed the validity of the proposed thought. This is the first model developed by me for adapting the temperature from the motor. Next. So this is the current adaptation model. So I need the signal from the main motor for the current to the PLC. So this model is developed by me.
Normally when you have this kind of things, you need to give normally when you have things of this nature, you're supposed to give explanation to those acronyms, like what is the AOV, what is the comparator, mux is the multiplier.
Explain.
Exactly.
So this is the move block from where the input.
No matter, but you should give an explanation.
Okay, sir. I will add.
Without an explanation, what does it mean? It doesn't mean anything to us. Outsider, how does anybody know what we are trying to convey there? So please, in your dissertation, that's all the more important.
Okay, sir.
Never put some blocks without an
I
explanation.
will noted this, sir. I will add all the details. Then this, and then the display and this same the signal will use in the PLC. So this is the sequence control. The build sequence, the on-off control is done by this sequence model. So logic is developed here, and based on the input signal, this model will work. And this is the main model of this, the reference control. All the signals are coming to this reference model, and then the output to the VFD is controlled by this model. So this is the sequence controller. So this will work with the on-off condition and with the running condition also. This is the basic difference in the sequence logic and the sequence controller, and all these things will go to the reference controller. This is the integrated model of that 5 module.
You should first start with this, and then start explaining other things, not the concepts. This is the overall view of the system, and then keep giving explanation to each of those subsets.
Okay, sir.
Right.
So this is the how this the PLC is interfaced with the hardware. This is the display, and this is the drives, and this PLC is connected with this drive, and these are the all the inputs to the PLC. So this to accept the higher speed above the 100% of the blower. So this modification done by me, that I provided the grill that the pressure inside this motor should not increase when it is required to run this blower above the 100% speed. Now this is the algorithm made for this system. Now this is for the DC drive. So the initial conditions, all the inputs are 0. The first step is to switch on the field. So yes, now if I switch on the field, then the blower motor will run at the 50%, and this is the voltage equivalent to given to the Ph.D. Then the next is the armature. If the switch on the armature, the field will fire at the 100%, so it is required to increase the speed of the blower motor. Then, with the run command, this motor will start running, and we know that the armature current is very low, so it is not required to increase the reference of the Ph.D. So it is controlling the temperature. Then the another conditions are the dynamic condition, and all these conditions are depends on the load. Next. So now, if the load is this much reference will release to the VFD. Then if the load change, this reference will go to the VFD. Yes. If this 100%, then the maximum reference will go to the VFD. Now, if the temperature increase above the 80%, so all these the conditions are bypassed, and this model will work with the temperature condition only. So unless and until it brings the temperature up to 80 degree, so all these conditions will not work. So that's why I written here that the priority from bottom to top. So this is for the AC motor. The basic difference is that in the static condition that the converter on is there, in that DC motor is the field on and the armature on.
Excuse me. What is the controller for your main DC motor?
Main DC motor drives, the main drive.
What drive is that?
So, DC drive.
Yeah, DC drive. Is it a converter fed DC motor drive?
Yes, sir. Converter fed DC.
So why is it that you can't control that based on your load?
Which drive?
In terms of energy saving.
Drive control.
Yeah.
So drive.
You can't
this
touch
one.
it, is
This,
it? You don't want to touch that.
DC motor drive.
Yes.
That we cannot control based on the load.
Oh.
With load, it is the requirement of the load. The drive is driving the load.
Okay.
We cannot control that drive based on the load.
No, listen. What I'm trying to convey is for the given load on the converter fed DC motor,
Yes, sir.
right?
Hmm.
Is there no way to, what I say is going for energy saving such that you do deliver the load, but with the power saving in the main motor itself?
Main motors are own made of power saving. It is that by fine tuning the parameters of this one speed controller and this current controller. We can do that, but that is the part with the this DC motor.
My hunch is probably you don't want to deal with, you don't want to touch that main motor drive.
Yes.
That is probably your hunch.
Yes, sir.
You don't want to touch that and mess it up, because or you are not permitted to operate the main motor from the point of view of energy saving. Am I right?
Yeah, we are operating the DC motor for the point of energy saving.
Oh, I see.
Yes.
Okay.
But this is not the part. That's why I got explained here. It's not the part of my research work. That we had already done, and optimum we are optimizing that system, the DC motor, by adjusting all the parameters to save the run the DC motor at the optimum level.
Okay. Please go.
So then these are the conditions for here. This is only the difference that the converter on. Whenever for the AC motor, whenever the converter on, the magnetizing current will flow through the motor. That's why it is required to. Now that's why it is required to run the cooling system. So next is the run command given to that this, and then rest all this will work on the load condition. Like the DC motor. So there is only the difference is that this is the converter on in the AC and DC motor system. So all these conditions are there. Now this is the configuration that what we had done in the PLC, connected the different blocks and all this. So now this is the complete animation at the how this control system, how this research will work. Now, now this the field on command is given. Now the field will fire at the 25%, and this the reference is done, and this the blower motor now it is working at the 50%.
Can you explain the whole block in the next 5 minutes? Because the reason is most of the people who have come,
yes, sir, yes, sir.
they will appreciate
So,
that.
so this is the PLC is
Okay.
controlling all these things, and the VFD, sir, we have variable frequency drive, and this is the blower motor. This is the main motor. Now this is the Siemens drive. So that's why, and then Siemens drive, this the feedback is given to the PLC. Then armature on feedback, it is going again to the PLC, and this is the temperature monitoring system.
Of the main motor.
Main motor. This is
Not
the
the
sir,
blower.
this is the
Okay.
main motor.
Okay.
Main motor, the temperature monitoring system. Now he has given the field on command. This is the field on command is given. Now the reference is at the 50%. Now you give the armature on command. So he has given the armature on given. Then he has given the armature on command. Armature on feedback will go to the PLC, and then this reference will change. According to that, the blower RPM will
What
change.
happens if there is a fault in the DC motor?
Yes, sir.
What happens if there is a fault in the DC motor?
If there is a fault in this motor, this will dip. The main drive will dip,
And that's
and then the field is withdrawn.
okay.
If this command is withdrawn, then this will stop. Then now he has started this DC motor. Now there is no load on the DC motor, so that there is no change in the reference of the VFD. What I explained. Now load the DC motor. Now he has loaded the DC motor. Now according to this, now this is changing and the reference is changing. So the load is changing as per that. This RPM was and this is changing, and this temperature is monitored through this.
What do you think? What do you think is the typical time constant of the so-called thermal time constant DC motor?
This one, no?
The DC motor drive.
Sir.
The so-called thermal time constant.
Yes, sir.
What is it?
Thermal time constant, sir. No, check.
Will be in milliseconds,
It is in the
seconds, or minutes.
thermal time constant is in the milliseconds.
Are you sure?
Yes, for the control, you are saying that for the
When
control.
I say, see, there is a armature time constant, there is a thermal time constant, there is a mechanical time constant. So what I'm asking is, what is the
This thermal time constant is in the seconds.
That's it. Okay.
So I thought that the controlling of this drive.
I'm not asking about.
Okay. It is.
I'm not asking you what the sampling time is.
No. Sure. So this is then for the AC motor. So this will work in the same manner. Yes, we go. So like that. Now this says the converter on command is given. Yes. Now this motor started. Now then the entire system will work on the load feedback. So the feedback is going from here to this PLC, and according to that, this reference will be controlled. So now these are the results.
Again, I have a comment only on this diagram.
Yes.
You must explain it clearly to me.
Sir,
I
this
mean, the idea is,
this
I want even the public at large to understand that explains very well the kind of ideas you have put in your thesis, mainly from that point of view. Please explain that.
Sir, nomenclature.
This is a very no.
This nomenclature.
When I happen to read from your summary and from the other material, I just couldn't understand the acronyms there. See, because whatever you have written now on the left hand side of it is not available in your abstract or summary, unfortunately. Okay, please explain. Go ahead.
So now this the blue one is this is here the blower RPM. So this blue block is the blower RPM. Then here it is written the blower reference. So this color is the blower reference, and then this is the motor temperature. This is the motor temperature, and then this is the motor current. So this one is the motor current. If the motor current will change, this blower reference will be
Please pinpoint it against the diagram. Pinpoint it against that pink color or green color, or pinpoint it. You have a pointer there.
yes, sir.
I don't see you pointer there. No, I don't see it. Are you able to see it? No, maybe it doesn't work or the battery doesn't work.
Reference, and this is the graph for the blower reference.
Okay.
Blue graph. Then another one is the now this is the blower reference.
Okay.
So now this graph is the
Okay.
blower reference graph.
Then how do you explain that overshoot and undershoot there?
So for this undershoot or overshoot, it is in the straight line. It means that the blower reference and blower actual is exactly matching.
Okay.
So then the motor temperature. Now this is the motor temperature, is different completely on the scale, and then this is the this one. Oh, zigzag.
If I were you,
This is the motor load.
Mr. Bunte,
Yes, sir.
if I were you, I would write over there temperature, there the difference speed, etc. Not put all those things in a small little corner at which I cannot even read. So the explanation of the diagram is very important, especially in the thesis writing. You got to be very careful there
Okay, sir.
because it's not industrial chart. You may read and you may understand, you may not understand. But in a thesis, if the examiner doesn't understand,
Right.
then you have confused it. Then that means the whole purpose is defeated.
Thank you, sir, for the suggestion. I will take this here in the text writing. So now here it is very much clear that the reference is following the load of the main motor. When the load of the main motor is increased, the reference will increase, and if it is reduced, the reference of the blower will reduce, and the RPM of the blower will reduce. But here we can say that there is no change in the temperature.
Then what is the lowest diagram? The diagram which is
So actually, sir, this is all this in the ready start. So that what the static condition I just shown to you, the ready start, run command, and all these are the digital signal.
Okay.
So I need to take the 0 point
These are not
here.
important. You
Huh.
should identify what is important in the
Sir, this is important.
Yeah, so drop this.
Huh.
You don't
Huh.
need that. It's
Remove.
confusing. It is confusing. What is this meant for? This is that. Who cares for the events that come in and go out? What you want to worry about is you got let's say a load torque, you got a speed reference, and then when the load torque falls, the speed falls. That's it.
Right.
It's on-off control. It's almost like a chopper. In this case, you are controlling the speed.
Right.
And my question here is, what happens if the duty ratio here is not small enough? In this case, the duty ratio is typically like 20%, right?
Yes.
I mean, or 80%, not because the speed has fallen to 50%, at least for 20% of the time. You save energy, right?
Yes.
If the period over which the speed doesn't fall, let's say below 50%, but 95% of the time, would you have power saving or energy saving?
Definitely, sir, we have. So that's why we had done this the data analysis, that what is the maximum loading of the drawing and at what load percentage it is. Yes.
Thank you.
Okay, sir. So now here the load on the DC motor increase, even though now the blower is running at the maximum speed, 100% speed. So now this is following the temperature. Now the temperature is not increased, that's why the blower reference is not increased here. Now here even now the temperature is start increasing. When the load is high, now this temperature is start increasing, even though the blower reference is strong, because the temperature of not increase up to the 80 degree centigrade. Now here the temperature is increased up to the 75%, so it had increased the 10%. Now here it increased up to the 80%, now again it increased up to 120%. And 120% is the limit given by me for the blower motor. Now after that the temperature is reduced, now the reference will start reducing and the go on reducing like this.
So, and most importantly here, the scale for the temperature could be different from that of the scale for the others, because the reason is the temperature variation is not much, but that deviation could be large enough.
Origin understanding.
Yeah. So consequently, the scale for the temperature could be different from the scale for all others. You don't express it in 100%.
Right, sir.
Express all of them into per unit rotation. Then it makes.
Okay. Now this is the final result. Here I want to show you that if the maximum saving is at the lower load side, if you go for the higher load side, the saving will reduce. Now from the 80% of the load, the saving is almost zero, because I am running the blower at the 100% at this 80%. Now here the load is increased beyond the 100% for the DC motor, so it is required to run the blower above the rated speed, so it will take more energy. But this gives the benefit to the industrial person that he can roll the higher load requirement with the existing setup. This is the beauty of this part. So even though the energy consumption is more, but the facility to the industry people is more in that case.
I think the most important part is you don't end up with a large scrap, and the cost of the scrap will be much more than the energy cost.
Yes, sir. Now this is the complete the actual power saving data recorded for the size 5.5. So for the explanation only, this data, the complete analysis will come in the thesis. Now this the operating speed in the previous condition and the present condition at given here, and it shows that the average power is this 3.7, and in old systems it's 11.3, and the percentage power saving is 67.26%. Now here this is I recorded for the December, January and February. So with the modified system, the working hours for the mill is 704 in the December, and the total time when mill is on the load is this one 355, and the delay with the off time is 101, and the delay with the mill on in hours this much. So the average power consumption when the mill on the load is this much. The average power consumption when the mill is off condition this much. So average power consumption when the mill idle this is, and the total power consumption in case the modified case is this one. Here you can say that in the old system the total power consumption is this one. So the power saving in terms of money, it is this much in the December. This is 3.7 lakhs, and in the month of January it is 4.4 lakh approximately, and in the February it is 3.7 lakh approximately. Yes. Now this is the average the power saving for the December, January and the February months. It is 3.81 lakhs.
Mr. Bunte, the most important thing for a thesis is not how much you save, but what is your contribution to the state of the art. That is very important.
What is the contribution?
What is your contribution to the existing state of the art or the subject? That it is for that you are given a degree, a doctoral degree. So this idea is very good. Basically the concept is fairly very simple, but you implement it in a large scale complex system. So in the thesis what you need to highlight is not how much money you save to a company, for that you are already paid, or you may be given an increment, or you may be given a promotion. But if you want to get a doctoral degree, you need to highlight most important part is how does this, what is the kind of, how did you rise the state of the art in the subject per se? That is what, that's what is important.
So this logic we can implement in the any other industry.
I doubt. I question that thought process.
Uh,
I mean, you can think about it.
uh,
We can't implement it at any place just like that. I mean, there must be reasons why you are able to implement it in this steel mill, but I doubt very much whether this concept can be implemented at all places. Well, the point is this: whenever there is the load is less, you.
the limitation of not using this system is that if the ND motor were always working at the 100% load, so this system will not work there. This is the limitation of this system. But the load change is there in the any industry, this system will work.
Okay, good.
Yes, sir. So now these are the conclusions drawn from this, that the acidity of this proposal will depends on the detailed economic aspects, the detail of the same have to be worked out for the concept process. Yes. Now this issue, that the issue related to the carbon credit, we are consider this, and this is only for the 3 months. We will check the saving of the rest of the month, and then we will make the conference report that how many we can say that, and then this we will include in the thesis. Now these are the paper published.
Are you writing your publications in the thesis in the same manner as you are written here? Yes, like journal publications.
No, sir. I thought the guideline is good. According to that, I will
This is not the standard way of writing publications.
the publications, sir, in the thesis you write it in different way.
So actually, here also you should write in that way, only, scientific way. Only.
Okay. So these are the references.
Conference you are written here.
Point in time, I don't want the public to be here, but I will tell you at what point in time you can take off. It means you can leave this place. Okay, that's because you don't have to know how I grill him, but you should know what he has done. That's important to you. What is the quality of work he has done? That's important to you. But the rest of it is between the candidate and the examiners per se. That is the typical in most of the top-notch institutions. I hope you won't get upset if we request you to leave at the right time. Okay? You've made a presentation. If we have any questions, I will leave you the chance to ask the candidate. That will not affect this call. If you have any questions, public at large, one or two, then I would go through the drill. If you have no questions, we thank you for your presence. It means you can go now. I told you, if you have no questions, then you can go. But we appreciate your presence. That's very important.
Yes, what is going on there? Why you are not asked question from there?
It's not a question, sir. My doubts, some doubts.
So
Then you can
why you
ask
are not
him.
raised from there? Now you don't disturb, please.
Yes,
Afterward you
If you
can
have a
contact
doubt,
him.
Yes, sir.
ask him afterwards. The answer.
Sorry, sir.
Don't interrupt
Yes, sir.
in the meeting. That's what the chairman said. Let me open up because I made my homework quite a couple of months ago. I just wanted to make sure. Most of your publications are basically those which are published in local chapters. It is not of high quality publications. And that is the first observation that I want to tell you. The second observation is your English is very poor in all those publications. I don't know whether you got it corrected at all or not. It is, I would say, I tried to go through all your publications, 5 of them. You have good number, you have presented them, but you are not careful enough in writing it properly. Either you didn't show it to your examiner, your advisors, or you just took it for granted that your advisor will approve whatever you write. That is the first comment I want to say. If you write your thesis in the same form, I can tell you, it shall get rejected. If you write your thesis in the same way as you have published those papers, publishing a paper is a very, very important task. It reflects your personality. You write things in an improper format or improper English, not conveying what should be conveyed there, it will be considered as a trash. No contribution. So, though you did good work, but you did not put it correctly. That is my first observation. I want to caution you there because I don't want you to repeat that when you are writing the thesis.
No.
The second thing is, there is a way or a format in which you are supposed to write the thesis. For example, you don't write in some chapter figure, in some chapter graph. You don't do that. There is a convention there. For each chapter, for example, let's say chapter 3, right? You have chapter 3 figure, 3.1, 3.2, 3.n. And if there are tables, again, table 3.1, table 3.2, etc., etc. That's the way you write. You don't suddenly change it to graph and suddenly change it to figure, etc., etc. And your figure should be self.
What I taken care in the writing.
Okay.
This one.
Anyway, but I didn't see that happening in your summary. I'll show you.
So after summary, where I have taken.
Okay.
I have taken that.
Then then all my comments, if you have corrected it. But the reason is I have not read this. I didn't have the time to read it.
No, some more connection. Okay.
That is the main thing that I want to say. Otherwise, tell me in 5 sentences, what is your contribution to the state of the art?
So my contribution is designing the control system
Okay.
for this.
What is novel about it?
So novel result is the logic behind that. It's the novel idea.
It's nothing great about it.
So
Nothing great about it.
so if I think it is if nothing.
It may be,
So
it may be-
nowhere.
as an implementation, it's great. But as a concept, there's nothing new in it.
No, as a concept is new, sir. This concept never used anywhere. Never used.
It was never
This
used.
concept, yes, sir. That's why it's the novel idea
No, correct.
for saving the cost. Because I referred all the papers and it is very clear cut says that the people work on the material used for the cooling. People used for that. What is the effect of that material?
What
on
is
that?
your first name? I just want to, your first name is Krishna?
Keshav, sir.
Keshav. I'll call you back.
No.
Keshav.
Very good.
Because I used to have a wonderful teacher by name Keshav. Because I don't really call your last name. Keshav.
Yes.
The point what I'm trying to convey is, I want to rag you such that you do better. I want to ask you this question because you should tell us what is novel about it. Because I take any induction motor in a very simple way. I take any induction motor which is a blower. I operate it at half the speed. The power is reduced. So
operating it at the half the speed is a very simple task.
yeah.
Okay, I can change.
All right.
But if making it dynamic based on all the parameters, okay, it's a difficult task.
Yeah, but
Operating-
what you did is basically you coupled that speed control of the blower motor based on the condition of the main motor and the load on the main motor. Am I right?
Yes.
Okay. So, under what situation? Most important part is if it has worked in some situation, I would say it won't work. Like you mentioned already, if the load is much more than 100%, obviously you don't save energy, but you still make sure that the whole system works. That's the essence of everything. So, to my mind, what is novel in this whole thing is PLC implementation, right? That is the best part of your thesis.
By
PLC implementation.
so sir, our basic logic idea we can implement through the PLC only.
Yeah, but
Or with the any logic system available. Like this the software.
okay, show me the
C++.
slide. What you think is the best contribution from it? Show me that slide. Just one single slide or two slides. I don't want to know anything about steel plant. I don't want to know anything about the boil mode. Just show me as a concept what is the most important contribution of yours in this thesis.
So that one the animation slides. Sir.
You show that.
No, you can't put animation in the thesis. Show me as a concept. You can't put animation in the thesis, right? Somebody should, when he reads the thesis, he should know what the concept is all about. Show me in what figure you have made clear this is my contribution. What figure or what para of this summary, this is my contribution to the state of the art. That is, in writing it should be there. I can't simply say I have expressed it, I have shown you in the form video or that. See, videos are not, then you have to put it on YouTube. For that you don't get a degree. So, please, that is most important part. Writing the thesis and explaining what your contribution is. I mean, saving is important, agree. But to get that saving, what is the concept that you have implemented it, and how this and you have made so many references. But nowhere did you say my concept is not conceived by anybody. You have put so much of it in the introduction, which is not generic to this concept at all, according to me. You talked about many things in the introduction. You did a good job in terms of introduction thesis. But most of it, to my mind, is not relevant to the concept that you are trying to drill in. That is the concept of energy saving, wherein you have an additional drive system or additional blower motor, and you control that such that you could have energy saving in a large scale system. That is a kind of thing that you have. What you have done is nothing but you put a blower in the loom for energy saving concept. That's exactly making use of a PLC and stuff like that. So in that, conceptually, you said fuzzy logic. Fuzzy logic can be implemented in a PLC. Do you know that?
Yes.
So why is it? And you said there will be oscillations if you use fuzzy logic, but you will not have that if you use the PLC. No, that's again a wrong statement. Because PLC is a means to implementation. If you have implemented it in a way that there are no oscillations, that's the
fuzzy logic, sir. I said that it is better to implement the fuzzy logic. I said that with the existing system, if you go for the fuzzy logic,
you know what a fuzzy logic means? You need to write the software code in fuzzy logic. That's all. The same thing. What all you wrote is you identify the. But writing the software code, it doesn't cost you 8 lakhs.
No, so if it is available in the PLC, it is available with the existing setup. Then what percent is 100% right, sir. Because if it is available in the existing, no sir, this is not available. We are having this one enhanced PID control. Okay? But that is not based on the fuzzy logic.
Anyway, so
that's why it is specifically written by me. And if you go for the new system, then it is better to implement the.
Then you should simply say it is not implementable in the existing PLC. That's what you should write.
That's the difference, sir.
Because PLC is a tool. It's not. Whereas fuzzy logic is a concept and a software implementation. So any microprocessor you can implement a fuzzy logic concept.
Right.
Any graduate can do that and should be able to do it.
Definitely.
So after all you have identified your inputs, your outputs, and then
Because now the new system, even the drives are coming with the fuzzy logic. Now this concept, one is the Bloom mill. There I am using this one digital drive. In this system I am not using the digital drive. Okay. If I go for the digital drive, the another concept is that this one the energy saving for the this one field. Okay. It will automatically go if the mill is not running for a certain 5 minutes. It will automatically go to the 25% field.
I just wanted to only raise one or two more questions. But let me tell you that this is an excellent concept that from the industry you implemented it and you came up with the possibilities for a doctoral thesis. I appreciate that thought process because I know what industry does. I have worked in the industry. I was a consultant to a number of industries. It's not easy to implement. And you took a risk of doing this in a large scale way, and your top management has agreed for that. That's the best part of it. However, when now coming back to the academics, if I wear the academic hat and I say, look, for what reason should we give you a doctoral thesis? Then you should be able to highlight what is your state-of-the-art contribution. That is very important. So, if you say that fuzzy logic is known and implemented in VFDs, it's not at all. It's not impossible. So, in fact, most of the times, this kind of energy-saving concepts are published in the literature for most of the motor drives. Whenever a motor is lightly loaded, there is a way to do that. You can use a VFD, you can use a voltage controlled. After all, it is a blower motor, means it's like what is the speed curve for the blower motor? Which is torque equal to square of the speed, right? So logically, you can do it also with a kind of a voltage controlled induction motor, not necessarily varying frequency, varying voltage, feeding the blower motor, but probably you expect much higher torque required at higher speeds consequently of that. But when I read that thesis 3 or 4 months ago, my first question was, okay, this is a good piece of work. If I were you, I'll take a patent and make money out of it. But will I get a degree? I don't know. So that is the part that you want to highlight clearly and most clear-cut terms. What that means is, okay, this is the state of the art that people have done. This is what people have done here, but I integrate these concepts into a state. That is the contribution. That is the way. Okay, how much you save is a matter of detail. As an academician, I don't care how much money you save, but what I say is, what is new in it? Tarnekar knows it. Right? Most of the times, when you say you are submitting a doctoral thesis, they will ask you, what is new in this? You don't get, just because but the way you have to claim the integration part of it as your contribution. In the individual concept like, okay, when I change the speed whenever there is reduced load torque, that's known. Obviously you save power, save energy. But in this kind of large scale steel mill, where you have the main motor, you have the auxiliary motor which is outside the motor, basically. That is I can say the blessing in disguise part of it. Supposing it is not outside the motor, can you implement it? Obviously not. Right? And the only question that I have there is, generally when you have a main motor which is operating at low speed, the cooling of the main motor is likely to be poorer. Right? When the main motor, whether it is a DC motor or induction motor, when it is operating at low speed but at high torque,
Yes.
let's say 70% of the speed, generally the temperature rise is supposed to be higher.
Right.
So at such points you can't reduce the speed of the blower, right? But your thesis tells me that you can reduce the energy because you can operate it at reduced speed. That
No, so
not
that part we not consider it. The speed of the main motor not considered in this research work.
Oh, then what are you considering? Only load?
Load and the temperature.
Where did you write that?
Huh?
You didn't write. I didn't read this
Yeah,
part.
it is,
No, at least I have not understood it. Let me put it this way. I spent enough number of hours on thesis. You never said that if the main motor, that means this is only meant for the fact where the main motor speed is constant.
No.
Or
Whatever the speed of the main motor, whatever the speed of the main motor, if it is running at the 200 or it is running at the 1500. Okay, so if it is running at the 200, then the heat generation is definitely more, and that means the load is more. Ultimately, the load is resulted into the heat generation.
But what I mean to say is you need to identify a logic by which, see, here is the speed of the main motor here is the load torque of the main motor, and then here is the temperature of the main motor, here is the armature current of the main motor. Then based on these inputs, how do I build a functional block which sets the speed of my blower? That is the kind of a mathematical optimization that you are worrying about. I don't see, you said optimization in a very vague terms. There is no optimization in the whole thing according to me. What is optimization built into this?
No, sir, optimization, we optimization in case of this blower motor, we are talking the part of this main motor.
No. You said you have optimized it to have energy saving, right?
Yes, energy saving.
When you use the word optimization, optimization generally means there is an objective function, there are constraints. The constraints, you have not defined what they are.
Constraints are the load and temperature, sir, in this case.
So then you have to define the ranges.
It is
It is
defined
what
that
range?
80 is the
80.
temperature range for the main motor,
Yeah,
and the 150 is the load range for the main motor.
okay.
So, without this system, it is impossible to operate the mode above 100%. Okay? With this method, we are providing the facility to the existing user of the these types of
Why
motor.
don't you
They
define?
can run the motor
I
above.
will give you a sheet of paper. Do you identify what is it that you have optimized? You can write it in one single sheet of paper. What is it that you have optimized with respect to what parameters, such that you have energy saving? Maybe I have not read it carefully, but I want you to write it in one single sheet of paper. I mean, you can send me that little later on. But the essence is, if I have not understood after reading so much, it means either I'm a dumb guy or I have not done it properly.
Yes,
Or
it indicates that whatever I written, that it is not up to the mark that anybody can understand.
basically, that's,
So this I accept that maybe there is a problem. I accept your suggestion that
because whenever you
definitely
use
I
the
come
word-
across this and the academic thinker,
Okay.
then I come to know that how to write this, all these things. Okay. So and from the beginning, there is a lot of improvement I had done. Now in that there is a lot of improvement I
Okay,
that
I'm not
with respect to
I'm not
this
done
one.
with such things.
Okay. So definitely, sir, this is that part. The accompanying part is the writing.
And
I really accept that.
And in a thesis, never put quality to term. You have to quantify it, and whenever you put a figure, you got to give explanation to the figure. Okay, I got these results, this is the figure. And you don't explain what the figure conveys. That's the way you are writing the thesis, at least in the summary part. So please make sure that your thesis is written. Other than that, I don't think I can say anything more than this. But otherwise, I compliment you on your work, on the concept and the implementation and the way you made it work. But I only caution you, I mean, if I were you, as I said, I'll first take a patent, not publish it. Because once you publish it, you can't take a patent.
Right.
And when you make money, when the company makes money, they should not let you publish it first. Okay? So that's what I would say. And if any of those fellows like Siemens or ABB, they get to know this, they will take this idea and put it, and they will apply for a patent in Europe or America and stuff like that. They make money, and then they will not let you do anything here in this country. They will say you are infringing on our patent. That's what can happen. And that, unfortunately, we in the academic circles, we don't stress that. We don't stress that. See, when there is so much money, supposing somebody is making Coca-Cola, there is a mixer there. Would you reveal that in a public platform like this and then say, okay, give me a PhD thesis? Forget it. Why would I need a PhD thesis? I will make millions, not billions. So the same way, if you think this is a wonderful idea, first you should have patent. Then take an Indian patent before publishing it. And then come up with other ways of doing it, because you're not looking for somehow getting a PhD and then you're looking for a job like others. So you have a job already, so make sure that. So, but otherwise, I have nothing else to say. I have stopped here. Let others comment. Maybe you could be advisor. I'll just stop here. I have done. I hope you got the essence of whatever I meant. My criticism is mainly to make sure that the quality is.
So you can learn from that also. It is always better to learn. So if you, the point of the mistake, what I had done, so I can improve the mistake. If nobody point out the mistake, then there is
Because this is just the reason why I don't want to publish it.
Yes, that is correct.
So I can't tell them you have published something which is, I can tell him not blank, okay, but I don't want to say that in public because that's not ethical.
Yes, yes. That is correct.
Okay, but don't publish in a great hurry and think of the consequences. That's the other thing. Because your academic senate or academic council will say how many papers have you published before submitting this so much. But you should simply say, I've applied for a patent, I have this, and this is an industry state of the art. And consequently, you can't publish it just like that without looking at the consequences. In the last 10 years of my life in the industry, they never allowed me to publish any paper, but they allowed me to take 50 patents. Okay? They don't, because industry people want to make money. That's how they are in the business.
Yes.
You want to create, you are in the business because of the students, right? But at the same time, the students are good enough and smart enough, they will leave the organization, start like Bill Gates, an organization elsewhere.
Yes.
So sometimes we have to balance up these two. Okay. I think I'm done with that, but go ahead on your side if you want to ask questions. Tarnik, you have something to add? Or?
no, okay.
He is such a nice person, that is a good part, but make sure that there will be bad fellows like me who will tell you what is wrong, and because the reason is, if I want to be nice to you, I should tell you what is not good in that part. That is the way.
I think very everybody pointing out that is there because all these things will consider in the our thesis.
If you have been benefited out of it, we are happy. Make sure that your benefited are made like
First time of presentation.